Hello, everyone. Welcome to chemistry. So I am going to go ahead and record our session for Thursday, December 10th. I will need to be canceling class, so I wanted to be able to go through this with you so that you could get the information about stoichiometry as we get started. So all of the same things still apply. This session will be recorded for learning purposes. We still have all of our same expectations. They just will be a little bit different because this is a recording. So let's start with lesson 601, stoichiometry and its uses, which I suggest all of you should be saying stoichiometry because it's a really fun word. So hopefully you guys are all taking advantage of that and saying stoichiometry over and over again. So the question I wanted to start class with, which you're not here to answer it for me, but I want you to think about, as we talk about stoichiometry, how is baking a cake related to chemistry? So if any of you have baked cakes before, or maybe cookies, you take all of your ingredients and you mix them together. And then you put it in the oven and it bakes. So there's a chemical reaction that's happening there. But the other thing that we need to think about is if we were to add in a teaspoon of flour as opposed to a cup of flour, we want to make sure that we have the right number and the right amount of our ingredients. So that is where stoichiometry comes in when we're talking about chemical reactions. So I want you to keep that in mind as we go through these lessons. Stoichiometry is the science of getting the amounts of reactants right. I do have a video link for you. I can't share it while I'm doing this recording, so I will include that link when I send out the link for this recording. So we must start with a balanced chemical equation. This is how we're going to start anything going forward. We need to make sure our chemical equation is balanced. So that's why we've spent a lot of time talking about that, working through how to balance that. And when we're thinking about a chemical equation, what a balanced chemical equation represents, it represents that conservation of mass, and it means that we have the same amount of reactants and the same amount of products. So this is where we're going to start really talking about, if we have this amount of reactants, how much products will we get? And that's the connection that we're going to make now with stoichiometry. And we're going to talk about this law of multiple proportions, which means that atoms combine in small whole number ratios. John Dalton was a scientist, and he was the one who discovered this and made other scientists aware of it. They didn't realize that when you start a chemical reaction, there's a certain ratio, and that's what you're going to end up with when you come to a product as well. There's always going to be that ratio because it needs to equal that conservation of mass. So that's our general, basic getting to know stoichiometry. The balanced chemical equation is going to give you that ratio, and the actual amount of reactants and products will be stated differently. So that's where we're going to start talking about this thing called a mole. And I don't mean a little rodent that's disgusting and nobody likes, or maybe you do, but a mole is something that we're going to start talking about, and it's going to become incredibly important as we continue our discussion about stoichiometry. So there is what's called a mole number relationship. And again, I have another video to go along with this. So I will include both of those links when I send out this recording to everybody. A mole, not the little furry animal that lives in the ground, but a mole, when we're talking about it in the terms of stoichiometry and chemistry, is a unit for measuring numbers of particles, such as atoms or compounds. It's really measuring those number of particles. So 1 mole of anything, whether it's carbon, whether it's yarn, whether it's cars, the 1 mole of anything is going to contain exactly the same number of particles. And that number is 6.022 times 10 to the 23rd. So this, I think we talked about it in October, where October 23rd is Mole Day. It was one of the days during assembly, and it's based off of this number, this 6.022 times 10 to the 23rd. It's a number that you're going to want to remember and memorize. I think last year the chemistry students memorized it by thinking of June 22nd and October 23rd. So that's how they kind of remembered it. Chemists have since standardized a mole based on 12 grams of carbon-12. So carbon-12 you probably have heard about all the time. Carbon-12 is one of those elements that is kind of universal through all of the branches of science. It's important when we're talking about carbon dating in earth science. Carbon is really important in the body when we're talking about biology, and it's super important in chemistry because carbon has the ability to form 4 bonds. So that's what makes it super special. So now let's talk a little bit about Avogadro. Amadeo Avogadro. What a name, right? His idea about particles and gas led to the development of the mole. So he's the one that sort of got scientists thinking about this and sort of like put them on that pathway of determining and defining what a mole is. It was actually Johann Joseph Lachmick who determined that there were 6.022 times 10 to the 23rd particles in a mole. However, that number is called Avogadro's number. So even though he wasn't the one that actually determined how many particles were in a mole, the number is still named after him. And here's a chart of some of the different conversions, because we will be talking about how to solve problems involving moles. I do have a problem in this slide deck, unfortunately, because I can't write on the board in this recording. What I'm going to do is I am going to include the steps and then how to solve it in a presentation that I'll attach with the recording link, because that would make it a little bit easier for you to follow along what the steps are. So 1 mole, as we know, is the 6.022 times 10 to the 23rd particles. 2 moles would be 12.04 times 10 to the 23rd, or if we wanted to put it in correct scientific notation, it would be 1.204 times 10 to the 24th. And you can read through the rest of these to see what it does. So it gives you what the actual, if we were to do 2 times 6 times 0.22 would be the 12.04, but to put it back in correct scientific notation, it would be 1.204. So this is the problem, how many molecules are in 1.2 moles of water, that I will solve for you and then include as a presentation within when I send out this recording, because I can't write on the board in this setting. I actually have a couple of them that I will work through for you. So that is our introduction on stoichiometry. It's going to be a lot of fun. If you have questions, please reach out to me. I will be available by email tomorrow. It just may take me a bit to respond to you. And I will also, there's also practice problems within your content, as well as within your chemistry problem solutions resource book that's within your resources. And the great thing about that is they will also give you the answers so that you know and you can check your steps. But that is our quick introduction to stoichiometry. I'm going to include with this recording, the 2 links for the videos that I was going to share, and then how to solve these 2 problems that I have shown you. So hopefully that is going to help you. If you need help further than that, reach out to me. And I will see you guys next week. I hope that you have a wonderful weekend, everyone.
Oh.